This video is going to show you some more detail about how to do electron configuration. So the first thing you want to do is to find the element that you're trying to write the configuration for. So we're going to start with carbon, which is right here. And you're going to, if you're not abbreviating, which we're not going to for these first 5, you're going to start on the top left corner at hydrogen every single time. So notice that on my periodic table, directly to the left of hydrogen, we have a 1. So we're going to go ahead and put a 1. On the top of hydrogen, I have a red S. And then if you count across, we're going to picture helium just for this activity as if it was right here. The reason they put it over there is because it belongs to that family, and we'll talk about that when we get to our periodic table unit. But we're going to pretend like it's right here, and notice you can go 1, 2, and so we're going to put a little 2 on top of the S. And the most electrons that an S can fit is 2, so you won't ever have a number bigger than 2 on top of that S. So just as a little reminder, that big number 1 is telling us the distance from the nucleus. So that means we're talking about the closest distance to the nucleus. The S is talking about the shape of the electron cloud. And then the little 2 on top is telling you how many electrons are in that cloud that the 1S is describing. All right, let's keep on going. We finished that top row, so we're going to go down to the 2. I'm right here on the periodic table. So we're going to go down to the 2. We're at lithium. And if you notice on top of lithium, we're still under the S hat. And we can go across to beryllium right here, and then we're going to stop. And we're done with the S's, so we're going to go all the way across here, keep on going all the way across till you get to that next one is 2. But now if you look on top, we're at the P section. And then we're going to count across to carbon, and we stop at 2. So 1 for boron, and then 2 for carbon. And this is the electron configuration for carbon. So that combination of letters and numbers is describing to scientists what the electron arrangement looks like around the nucleus of carbon. All right, let's do the next one is argon, which is way over here. Just like carbon, we're going to start at the 1s2, and that gets us across that top row with the hydrogen and helium. Then we're going to go down a row to lithium, and now we're at 2s. Count across 2. That gets us to beryllium. All the way across, keep on going till you get to here, and we're at 2, but now we have a P. And if you count all the way across for P, you should get to 6. So the most that you can fit in the most electrons you can fit in a P orbital is going to be 6. And that gets us to neon. So now we're right here, and we're going to go down to sodium, which is down here. So we're now at 3s, 2, gets us across to magnesium. And then keep on going all the way across. Here we are all the way to 3p. And for argon, we're going to go all the way across. So we're going to put a little 6 up there. And that's the configuration for argon. And let's skip down in your notes and do germanium next, because it's just a little different. So germanium is right here. I'm going to go a little faster at the start because it's the same as carbon and argon. So we're going to do 1s2, that gets us across the top row. 2s2 gets us to beryllium right here. Go all the way across till you get here, and we're at 2p. All the way across is 6. That gets us down here to sodium, which is 3s2. Go all the way across this gap here till you get to the 3p. All the way across is 6. Now we're down to 4s2, and now is where it gets complicated. So notice that right here we have 4, and right here we have 3. So the D will always be 1 less than the S that you just wrote. So it's tempting to write 4D there because you just wrote 4S, but because the orbitals overlap just a little, it actually goes down to 3D. But then, and if you count across for D, you can get to 10. That's the most you can put for a D. But then notice that right here, the P is back up to 4. So the S and the P, these numbers right here, will always match, and the D will always be 1 less. And then we're counting across to germanium, so you should get to 2. And, whoops, sorry, that was for germanium, not fluorine. And now I want you to do fluorine and potassium. So take a minute and pause this video and try them, and then check your answers. All right, check your answers for potassium and fluorine, make sure you got those right. And then I need to show you a few more things for this lesson. The next one is the abbreviated ones. So scientists don't want to write pages and pages of electron configurations, so they have figured out a way to abbreviate so that you're only talking about the electrons that are on the very outside of the atom, because those are really the only ones that matter. Those are the ones that get traded and borrowed and stolen and used during a chemical reaction, and the electrons in the middle of the atom are kind of stuck in there, so we don't really care too much about them. So let's go ahead and we're going to start with calcium. And calcium is right here, number 20. And what you're going to do is go up 1, so we're going to go up here to magnesium, and then you're going to go all the way across till you get to the end of row. And you're going to pick argon. And these are the only 6 elements, these right here are the only 6 elements that you will use when you're abbreviating. So we're going to put argon in brackets. And what that means is that you're including argon in everything before argon, and since argon is number 18, now you can start with element 19, which is potassium right here. So instead of starting at hydrogen at 1s2, now you can start at 4s, and if you count across to calcium, it should be 2. All right, let's do another one of these abbreviations. Selenium is over here, number 34. So we're going to go up to sulfur and then all the way across, and again we're going to have argon in brackets. And then we can start at 4s2. Don't forget about the overlap, so then we're going to go down to 3d, and all the way across for D is 10, and then back up to 4p, and we count across 1, 2, 3, selenium is number 4. Let's do one more and then I'll let you try some of these by yourself. The next one is strontium. And strontium is right here. So we're going to go up to calcium and then all the way across to Kr, krypton. Then we can start with the element after krypton, which is 5s2. And we're done. That gets us to strontium. So pause this for just a minute and go ahead and try magnesium and cobalt, and then I need to show you those last 2. All right, check your answers for these 2. Magnesium, you go up to beryllium and all the way over to neon in brackets, and then it's just 3s2. And for cobalt, cobalt is right here in the middle of the D's. You go up to that blank space on top of number 27, and then all the way over to the right to get argon in brackets. Then you can start with 4s2, and don't forget about that overlap down to 3d. The last thing I need to show you is how to get down to the F block. So first of all, let's go ahead and do lead first before we do americium. Lead is right here. Just like before, we're going to go up 1 and all the way over. So we're going to put xenon in brackets. Then we're going to start with the element after xenon, which is cesium, and we're at 6s2. Then I want you to notice this little green star between La and Ba that I put right here, and you're going to follow it down till you get down here to 4F. So anytime you get to that space between Ba and La, you're going to follow that down to 4F. And if you count all the way across the Fs, you should get to 14, and that finishes at Lu, and then you're going to go back up to the star and pick up where you left off. And that's a 5, so we're at 5D. All the way across is 10, and then we're back up to 6p, and for lead it's 2. So notice that these 2 numbers match. The S and the P will always match. D will always be 1 less, and then F is going to be 2 less than the S and the P. All right, our last one, I'm going to do americium down here. Our last one is americium, which is right here on the F block. And while it's tempting to put Lu in brackets, because if you go up to Eu and all the way over, you get to Lu, you can't use Lu because it's not a noble gas. So what you have to do is to pretend like these 2 rows are actually in this part of the periodic table, because that's really where they are. It would stretch out the periodic table a long way, but they would actually fit there. They would fit where the stars are, actually. So if you're going to pretend like 4F is in the 6th row, then you would use xenon in brackets. So any of these elements, you're going to put xenon in brackets to abbreviate for them, and any of these elements, you're going to use radon, and you might want to just label that on your periodic table. So we're on the very bottom row for americium. Here's americium again. So it's kind of like we're in this row right here. So if we go up 1 and all the way over, we get to radon. So we're going to put radon in brackets. Radon is number 86, so then we're going to start over here, number 87. So we're at 7s, 2, that gets us to Ra, and then again, notice this star right here that I drew on the periodic table, follow that down here to 5F. And then let's count across 1, 2, 3, 4, 5, 6. And that is the abbreviated electron configuration for americium. So your progress check today has some practice problems, and we will go over those in our live meeting.